Now just in general, if we think about volume, the volume is that third dimension. So if we have something, for instance, that we know the shape looks like this, and then we were going to stack those up as they come out here, that has an area, and if we had that area as that figure came out from the board, then we could add all of those up, and each one of those individual areas, when we added them all up, would give us a total volume. We do the same kind of thing here. We look at this figure that I formed and say, okay, what I really want to do is I want to know, what does it look like to slice a piece of that out? Slice a piece here. So look roughly like that, okay? And if we were able to just take a knife and slice that out, when turn that thing sideways, what would we have? Well, we would have a circle, right? Now, the circle there has a different diameter than the circle down here, which has a different diameter than the circle up there. But each one of them, because the edge of this is defined by the function, each one of them, we can get what that area or that radius is, okay? Think about from here to there. How far is that? Well, that direction right there, you say, well, it's coming from the y-axis where x equals 0, right? And how far is it going? Well, it's going out here to some x values, whatever x is. Now, in this particular case, what we have is we have y. We don't have x defined, we have y defined, right? And so in this case, because of the fact that what we want to know in order to determine a radius, and if we want the area of this, of course the area is pi r squared, we need r. What is r? R is the x distance from there to there. That's what r is. So I need the x distance. Therefore, in this particular case, what I need is I need to solve this for x, because that's what I want in my formula. So if I solve this, I say y minus 2 equals x squared. X would equal the square root of y minus 2. And you may say, well, that should be plus or minus the square root of 2. And I would say to you, not in this domain. In this domain, it's just square root of y minus 2. And so that is then what x is. So x is 0 on the inside. Out here on this edge, x is square root of y minus 2. It matters where we are, okay? And because what I'm doing is I took a slice this way, I'm going to take another slice this way, I'm going to cut it like this, and I'm going to be adding all those things up in the y direction, that tells me that the direction I need to integrate in this case, would be in the y direction. So I'm going to end up with an integral, and I'm going to need the area, which in this case I want to be a function of y, and I'm going to need to then, the direction that I'm going in is the y direction. So because this slice that I've made is a delta y slice in the y direction, I will be going dy. Now if I think about, well, how much of this do I need to add up? Well, the lowest y value is 2. The highest y value is 6. So my integral would be from 2 to 6. What is that area? Well, I need that area to be in terms of y. I know that the radius is this. Therefore, pi times the square root of y minus 2 quantity squared. So it's just pi times y minus 2. I then actually put this into the formula. I said I'm going to integrate from 2 to 6. Pi is a constant. I can bring that outside here. I've got y minus 2 dy. Once we get to the point in these integrals of actually doing the integration, sort of like with the partial fraction decomposition that we did before, the integrals themselves are not particularly challenging. I integrate this, y becomes y squared over 2, minus 2 becomes minus 2y. I need to evaluate that at 6 and at 2. 6 squared, 36 over 2 is 18, minus 12. And then subtract what's having a 2. 2 squared is 4, so that is 2 minus 4. And I'm left with 6 minus a minus 2, which is plus 2. And the answer they get is 8 pi. And by the way, in these types of problems, almost always the answers in the back of the book are left in terms of pi, not as some decimal value, 24 point whatever, that we would get if we actually multiplied this out. So that's the volume that's formed there by rotating around the y-axis. Now, in addition to rotating around the y-axis, we can rotate around the x-axis also.